developing any application or any projects. For example, if you want to develop an HTML, you cannot do that in Arduino. You cannot do HAL code in Arduino. You cannot do Arduino code in that IDE. So, do you want to add up IDs more and more? No, right? You want a single solution. That's where VS Code comes. And one more thing, what we saw is platform IO. It's a still developing thing, but it has support for most of the boards and different frameworks in a single thing with a single command line utility, and it also has a VS Code extension. So everything boils down to VS Code and installing extensions. So let me show you how I can set up a project with locally in VS Code using this. Just a minute. Okay, so I'll share my screen. So this is VS Code and how we can set up simulation that is going. Uh, the simulation is actually not running offline, but the compilation happens offline. So you see, this is an Arduino code, like the setup and loop thing. I hope the font size is clear for you. Uh, right. So you can install this walkthrough extension and the platform IO extension, which is this one. Right, this is the platform IO extension. If you open this PIO home, sorry, this one open. Yeah, it will open this PIO home page where you can create projects and things, import project, Arduino from projects. And the thing is, a good thing about platform IO is that now we have platform IO simulation. Like all different type of frameworks is supported, all boards are supported, and simulation is supported all in one place, right? And also this is the UI tool, right? I have also installed the command line utility in my systems. So because I used to do things command line, so I have installed the command line for platform IO. You can see the platform IO for how to install in your specific system. Linux, it may have some packages. So I am using an Arch-based Linux. So I used a package manager called Pacman to install it. Your systems will have package managers, and Windows will have certain thing. You can refer the platform IO website for how to install on your system. And now let's create new project. You can create projects using this window where you can specify the project name, frameworks, and the board, and it will create you a new project. Okay. So let's say our project name is uh, LED Blink. I think I have some doubts. Okay. Fine. So if I am speaking too fast, you can tell me so that I can slow down. Okay. Okay. Creating a project. So you see, in this platform I go, you have uh, these are manufacturers. These are Fruit, Alorium, these are Arduino, all are manufacturers and their different boards. And these are microprocessor, generic processors, uh, Raspberry. I think Raspberry is not there. Spark, one tiny. I think many things. Let's search for. Uh, Ras- yeah, Raspberry Pi is also there. And what else is there? STM boards. Let's search nuclear. Yeah, these are the nuclear boards. Just the nuclear boards that you can select. If you are using any board, any framework. So these are the frameworks that are available here. Arduino framework is the setup loop based framework, and you have STM Cube framework, which will be using STM Hall. You have seen STM Hall, right? And these are the other frameworks that people use. For STM board, we use this framework. You can also use Arduino for STM Cube, and STM Cube cannot be used for other boards. So that is the specific board for STM32 only. But Arduino can be also used for this. And there are these are different halls, hardware abstraction layer and frameworks that people use. So for simplicity, we'll only follow these two frameworks for our workshop. Maybe today we'll use Arduino and tomorrow we'll use STMQ. And I'll also show how you, in tomorrow's session, I'll also show how you can generate code using CubeMX and how you can again, program using XCM Hall. Okay. So today we'll see the project structure and how you can structure this project using platform. Okay, so you can easily learn the Arduino IDE or the STM IDE using the internet, but these are the things that you won't get to know from searching on the web. This comes from experience, right? Like a lot of searching is required to find the perfect setup that you need to do any type of project. Okay, so let's start how we can set up these things. So there are two parts. This platform IO things. So when you initialize a platform IO project by selecting the boards and things like that, you will get the platform IO.ini file. That ini file is kind of a configuration file. So that have what is the platform that we are using, what is the framework, and what is the board. Simple configuration thing. So for example, so that can be also managed using project init. So this command is there. So this command actually helps us initialize a project. You can select a project and initialize it. So let me show how I can do that. So this is my folder. I can create a new directory. Uh, Platform IO test. So what I'll do, platform IO project init help. So you can use this help to display what are the things that is needed for that. So project directory is needed and board ID is needed. So how do we know the board IDs? So you use the visual thing, right? But they have a different IDs in the local. So for that you can use platform IO board. So here it will search for boards. So for example, if I want Arduino Uno, so I'll search Uno. Uh, and you can see what are the MCUs that matches this Uno thing, all coming from different things. But this is what we want, right? Uno, this one. So the ID is Uno. So there are different IDs for different boards that you can see here, right? For nuclear board, nuclear board. Uh, F series. Check F series. Okay, yeah. So using underscore for these things. So all the different boards that are there are present here. Oh, so we'll now just use the Uno. So we know the ID, which is Uno, and we can initialize the project. Project is Uno, and the platform directory, right? Which is uh, it's again projector board. So we have to use this D for board and D for directory. So this is fine. And you have this ID selection also. These are the different IDs that platform IO can work with. We are going to use VS Code. Maybe we'll use VS Code. So it is creating a project for us. So we can CD into it. and open VS Code from there. So now this is how a freshly initialized project from platform IO will be. You can see the platform IO will have environments. So you can have multiple environments and multiple boards and frameworks that are that your project is using. So it's not only related to you only cannot do only you can also develop for board other set of Arduino boards in the same project also. So you can configure the environments as needed. That's what the specialty of this is. Like you can develop same project for different boards in a unified project structure. And you have this src file. Now it is not populated. It should be populated or just check. Yeah, these are the things that are there, and we'll create a main.cpp. And this is our project file. We'll include arduino.h and void setup and void loop. We have our functions. We just have this for now, and we'll go to the terminal. And how do we compile it? Platform IO. There is a command called platform IO run, which will run the build scripts for you. You can see that it is built into a file. So there are different files that have been built. So there is this ELF file, and the X file. So these two files are needed for us to simulate. So these are the compiled binary files, so which have the program that we need to run, right? So to use to simulation to add the simulation thing, the walk we set up, we need two more files to this project. So what are the files? So we need in walk we that so here sorry, yeah, this one. Oops, yeah, project configuration. So in a walkme project, we need this walkme.toml file and a diagram.json file. So I hope you are aware of this diagram.json file, which is used to denote the diagram thing. And you have, which is a JSON file, and you have walkme.toml, which configures basically the firmware path and the ELF path. So we know these paths from our compile command, right? Here. So this is the ELF file, and this is the X file, which is compiled binaries, right? So we have to link these two things in the walkme.toml file. So we'll copy these are this is also a configuration file. This 2ml file is also a configuration file basically. So diagram.json is also another form of configuration file, and the platform mini is configuration for platform IO, the project setup. Walk V is for simulation, right? Now we can set up this uh, walk V the 2ml, and our paths are here. This is the where and just the same thing with the elf extension for it. We have to specify these two files. And one more thing, once you install this walkme, you can access and start the walkme thing by uh, so before that, one more thing we need, which is the diagram.json file, right? So in walkme, the VS Code extension, you cannot edit the diagram.json file. So edit the diagram.json file in the sense you cannot edit it visually like this as you do here. That requires a subscription. That feature requires a subscription. But and that diagram editing feature and offline running feature. So the simulation happens online actually. So the thing is that requires a license. So for that, now we'll design using the online at what we will set up the diagram and then just copy paste the diagram.json to our project. So it will by default using opens using the diagram editor, but we cannot edit it here because if you want to edit it, you have to purchase the plan. What you can alternately do is you can copy edit it there and paste it here. So you have to open with text editor so that you will have diagram.json. So what we do for our project, we'll put the diagram.json uh, here and the main.cpp here and our visual diagram.json over there. I think we can close this because we won't be able to edit that. This we don't need anymore, and this also we have configured, right? And now we'll start what we. So you can use this Control Shift P. I think that would be the command for opening up this command palette in VS Code. Using that, you can just search walkme and the start simulator option will be there. And initially, when you start in the simulator, it will ask for a license. So it will open up a home page. There you will have to generate your license by logging in into walkme. So this license is free for only paid for commercial use. So since we are not using commercially for open source projects, this license is free. So you can use that, right? And now we are going to start the simulator. I have already installed the license, so you can do that. And then now when we start this simulator, it will open up this new window for the simulator. Put it to the sides. And there is nothing like maybe sometimes we need to have to reload this thing, so you can reload the window. Okay, it's not found. Okay, so we have built it, right? Files, files are there. We'll start the simulator. Yeah, now it's done. So the simulator will open up, and this terminal will display the output that is coming from your Arduino, the serial monitor like thing. Now we have the setup and loop, right? So we cannot do the editing over here. You can see that you cannot do the editing over here, but you can edit using edit the diagram using this one. So we'll copy the diagram from here with an LED. Oops. So we have already copied the diagram. That's right. Now we have to write the code, right? So the initial blink code that we wrote, what is that? That is LED equal to 50. We'll set up the pin mode to output. Now it is digital write LED pin I usual blink code low 1000 and yes, fine. So now how do we compile it? We go to our terminal. So this is the my compilation terminal, and I run platform IO again, and you can see the LED starts to blink. I can change the delay As soon as I do this, like compile, you can see the LED blinking faster. See, the now the LED is blinking at a zero point 0.5 second interval. So, using a local machine for compilation, we can avoid the waiting time that we see in what we simulated, because it uses their server to compile the code, right? So now we have a unified project management setup for all kind of boards, like most of the kind of boards and projects. So till now, anyone have any doubt from what I have said? How to get the license? So the license, if you run it for the first time, it will automatically ask you for get. Here you will get a prompt for getting the license. If you want to renew your license, you can use Walkme uh, and request a new license. This one that will open up a new tab. I hope you can see the tab, right? You have to be logged in, and then you can get your license by clicking on it. Then it will redirect you back to the Visual Studio Code, so that key will be already added. If you want to manually enter the key by copying from here, you can copy it and use the manually enter option in the VS Code using here. So how do you open up this? This is called the command palette in VS Code. How do you open up this? Using Control Shift P. So that is the shortcut, or you can use, I think, view command palette. That will open up this thing. It will have commands that you can extension commands for the extensions and VS Code everything around here. So start simulator command will be so opening up this. Right? Is that clear? Oh. So any other doubts? How about my speed? Am I going fast, or is it fine for you guys?
Sir, a little, please explain a little bit slower. You are going fast.
Okay. Okay. So till now, like how many, how, okay, let's do a quick poll. Just to put how much percentage of what I have told you have got into it. So can people put that in this chat? How much percentage of things that, okay. So okay, I just want to ask this general question. So how much experience that you people have already in this embedded programming? So how many beginners, like total beginners, are there? Okay, how many have? Okay, one. How many have you have done? Okay, two. How many of you have done one or two basic projects in this embedded systems or microcontrollers? Okay, okay, yeah, a few. Okay. Any experts? Okay, fine. So with that, uh, so there are three things that I want to emphasize. Uh, so the things I want to emphasize is your uh, IDs. We have IDs, right? Or do you know STM, you, and different IDs for different things. So what we need, an unified ID. You need simulation, project management, and configuration, right? Like flexibility. So, and a development environment. So, each providers give different IDEs, right? And they have some support and something not. Since the nature of Visual Studio Code, what is the solution? VS Code. Because oops, oh, this is visible. Extensible. Because we have extensions, right? Supports walkway and platform error. Okay. So why it is difficult for different people to compile the code and things? So actually, what happens when you compile it, you only have this main.c, right? But what it doesn't have, for each project, there needs to be in olden days. What people we will do is create a make file, so that will have instructions to compile things around that. And if you see, what is this? Basically, the Arduino libraries that are there, all CPP files. Okay, these are the compiled files, so we cannot actually see it. The output files, compiled output files. So basically, what is there is the compiled files. Uh, this platform ever tool can support compiling different frameworks. You can compile the Arduino code. You can compile any supported boards in any supported frameworks that require some libraries. So you see, first time when I installed it, you can see these tools manager are downloading. So the required tools, the platforms, the hardware files, the debugging files, what are the tool chains, the tools needed to compile that, the libraries needed, everything is found by platform IO. This platform IO provides us more support than any other existing IDE while considering this project management. So for simple cases, you can use the Arduino IDE. If you want to just quickly share a project or quickly do something, you can use the IDE. But in a software development things, what people used to do is do version control and stuff, right? So how do you use version control? You use Git. So there is something called Git, and you can actually easily initialize. This is a reproducible thing. Anyone can just clone it since this has platform IO configuration. They just have to install platform IO, and for any board and any framework, they can easily able to compile things. You don't have to worry about the other tools. So the things you need are VS Code and platform IO. So these two things you can develop embedded system, like any embedded system or microcontroller projects with these tools. So there were different tools and handmade tools which were used previously, and platform IO is closing the gap on that. And WalkMe is closing the gap on simulation. So to learn embedded system, you don't need a physical board or a different set of IDEs. Everything is in one place, right? This is a good thing for us. Okay. And you need certain configuration file like diagram.json and walkme.2ml for is that you can easily get to know about from the documentation that I have showed you, and platform io.ini will be automatically configured for you. So for example, if I want to add project here, I can actually add. You can see there are other things that are there. Initialize project or update existing project and things. So let's see the other boards. Mm, let's see the board that workpiece has. Another board that the workpiece has, and we'll select that board. Uh, an Arduino Omega is there, right? So okay, we'll search for Arduino Omega. So Arduino. Oops, uh, a whole bunch of things here. Okay. Uh, this is select the platform Arduino. This is sure it is showing everything. This is not sure about this. Boards. Arduino Mega is there. Its name is Atmega. Okay, that was the name. So if you want to develop for that, hope same project will support this one. Maybe, may not be. That's based on the compatibility of the boards, like whether it will work on that or work on that or not. That is there. Okay, maybe I'll instead of this, we will take the board, take nano. Yeah, this might be it. No, this one. So, copy that. Add platform project. Init. Now you can see that code is also added here, right? Now, if we use run, You can see the same project is being built for both the things. Like this is now building for and Arduino, and the same thing is built for the Nano board also for this board. And you can see this in VIO. There will be two folders where this is done for the Nano. That also you can configure separately, right? And then you can also simulate that over here. So basically, using this, you can develop projects for multiple boards in the same environment. So these are the things that you have, right? You can also write tests that if you want. There are some local simulators from which you can write tests, and you can include that things here and things like that. Okay. So you need some time to get to used to this command line interface if you are not comfortable with this, but you can always ask for help. It will show the list of commands and you go one by one. What are the different options that are there for this, and you can explore this thing. Okay. So the things that we used are project for project management and run for building the project. That will generate the firmware files that we need to use for simulator. You can also upload using this itself. I think there is a device. Yeah, okay. Yeah. For run, if you use run when the board is connected, it can also upload the code there. Okay. So those things you can try out. For now, we have this thing all set up, and now we can do whatever things that we did here over there. Yeah, do you get the idea? Is that okay?
Yes, sir.
Oh, oh. So now we'll discuss about what are the different programming patterns and uh, how we can connect different components and things like that. So the codes that we saw yesterday are actually doing this one thing. Like we give a specific task and it does the same thing over the loop, right? It is not doing anything different other than what is like anything different means only one task we choose and one program was dedicated for that particular task. So for an example, how do you do things when you want? mm, so it's create a project. When you want the board to do multiple things at the same time. So how do we do that? So now the idea is I want to blink an IDE, LED, and also that one LED will be blinking with a 1,000 interval, and other LED will be blinking with the user's button press. That is the idea. How do you do that? Any idea? I think we can start from project yesterday's thing. That would be better. We'll just do this. Okay. So now now we have this diagram set up. So this LED, let's have the red LED will blink at a 1 millisecond interval, 1 second interval, and green LED should blink when I press this button. That's the idea, right? And also, if you want, you can add this, uh, like add one more LED and change its brightness with this one. So three tasks in the same thing in the same program. That's what we are going to do now. And maybe we can add a fourth LED. So now it's time to get make our project complex. So that's the idea. So since now we have our, I'll add two more LEDs to uh, do that.
So can you tell the task again?
Okay, okay. So for the yesterday's thing, we did one code at a time, right? In one time
Yes.
for one compilation. Now we are going to do multiple at the same time. Okay. So this board is going to do different things in the same program. It is going to read the input and change this LED's brightness, which is this that's the blue LED, which will be connected to a PWM pin. I'm going to connect this here. Sorry, connect this over here, and this will be down. This blue LED is going to change its brightness with the potentiometer. The green LED is going to turn on and off with this button. Red LED is going to blink it with an 1 ms delay, 1 second delay, and we are going to add an yellow LED, uh, which is another LED. This will glow if motion is detected over here. That was the idea. Maybe I'll delete these connections and make it clear so that just give me a second to uh, make the diagram cleaner. Otherwise, it will look totally messy. Just that. This one. This one. This one. Okay. Now, uh, we'll connect this to. This one thing. Yeah, it's don't spend too much time on this. I think it's still taking time. Just connect it. Sources. Ground. 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 So now this pin goes to 13. This one uh, is going to 12. Made this better, but I think if you have time, you can do that. This one will be going with this. anymore where which one is connected. So this is in 10 and this is in 9. Select this to 9. So let's have that one like this, and this one is connected to its maybe I think just it's higher uses some flexibility from the rear score. See, which is connected to the splitter. Yeah. Connect this one to pin 8. So I think it's much cleaner. Right? Now you know what is where, right? So now I'll just copy this diagram.json for us now. I think I have to keep this where this is an analog. So it's also a digital thing, right? You have to connect it somewhere. Okay, I think you connect this to this is an input thing, right? So it's an uh, digital input thing. We need a digital pin. So okay, I'm connecting this to uh, now this to 7. So this is the best I can do, I think, for now. So you can, so as long as you can see the wire properly, it's fine. Okay, I hope now things are good. Everything is connected properly to the things we need. And now we'll copy the diagram of this. That's what we do. And now we'll change the diagram of JSON. Again, you have to open it using this mode. Where we'll paste this diagram.json and we'll stop this and reload the simulator. Start simulator. So you'll see the new diagram that's coming ahead. And the program is same, right? Program is there for blinking the LED 13. That's why you see the LED 13 blinking over there. So now we'll come over here and maybe zoom a little bit. Okay. So now let's go to the main task. So now what's our objective? So our objective is to write a single program that blinks this LED one, which is we'll define the LEDs, the components first. That way it would be easier to see. Int LED one, LED one is in pin 13 red, LED two is in pin 12 green. Oh, I have to add this one. So you see, you get some good linting, which is a feature of this VS Code, right? LED 3, uh, it's in pin 10, it's blue. LED 4, which is in pin 9. Okay. Now, our task is task 1, blink LED 1 at 1000 ms. Right. Task 2, turn on and off green LED 2 with push button 1. button is equal to is connected to 8, and push button. So let's do these things, two things, right? Okay. Now we have already the first task is completed. So then how do you do the second one? Any ideas? Anyone?
Like
We will add the
changing the
code here.
brightness according to the potentiometer.
No, no, just this one to here. So this is connected to pull up mode, right? The
Yeah, we'll
button with
do.
green LED. So pull up mode.
So like we
So
should
is
provide electricity to it. Like what we did it is,
yeah,
we pull out. We should pull in for
yeah,
the green
LED
bulb.
two. We set the input mode to pull up. Input pull up. Right. So this one is now LED one, since we have redefined it. So I'll change that to there. LED one. That's okay. Now we have LED. This is set up. And how do we go over this? So the code that we wrote yesterday, for that one, that specific case, task one. For task two, what we did yesterday, we did digital write of the LED two. We will be writing the opposite of digital read
Digital read.
from which pin? Push button.
Push button.
This is what we did.
7.
It's
Yeah.
actually defined there, right? We have defined it
Yeah.
over there. Push button is connected to 8. So I'm just using that over there. That makes sense, right?
Yes, sir.
So okay. Now let's turn this to 1000 ms. Now we are going to compile our thing. So this is my terminal. Going this, and you can see this LED is on now. Why is it on? It will be right. To pull up from, why is it doing something different?
We haven't set the delay time.
Yeah, that's because when it is doing this, it is not doing this because it's waiting here without coming to this line of code, right?
Yes, sir.
So that is blocking the other tasks code. So this is a blocking delay. So these are the basic concepts that we should know when we are doing this kind of microcontroller programming, when the projects actually go there. And one more good practice on doing these things is using Git to version your code. So if you are familiar with Git, I should have made the first commit when I have set the project. And as this task grow, I'll use another commit to save the state of my project so that larger projects will be easier to build if you are going like this. And you have the source code in the local system, and you can see it anytime, and you can compile locally. Only thing you need internet connection to see the visualization. That's it. If you have offline board, everything is set up in VS Code itself. The uh, for me, VS Code is my home page kind of thing. When I open up my system, I always go there. Most of the things that I do in VS Code, right? So I need everything. It's an all-in-one app for me. Okay.
Yes,
So
sir.
okay, now let's how do we do that? So here in Arduino API, they provide another function called millis, and there is also this micros if you see, which is microseconds. This millis function actually returns a number like the number of milliseconds that has occurred till the startup. Okay, so that's what millis provides. So what we usually do in case of this blocking delay is we add a delay like we need to store the last time the state changed, and when it is actually time for the LED to blink, then only we change the state. So that's the idea. So how do we do that is we define another thing, last LED, last LED change time. Can start that to C, set that to 0 initially. It's a global variable, right? And now what we can do is, if last change time millis, so millis will give us the current time minus the last LED change time. This two, this difference, if it is greater than 1000, what we'll do? So now let's ignore the second task. We'll change the state of the LED one. So how do we change the state? We just read it and write it back, but the opposite. So what I'm doing, I'm reading the value that is there and negating it and putting it in the value. Do you get the idea how this is happening? Now, whatever the state is there, if and what one more thing that we need to do is, now we have changed the state of the LED, so that we have to update the last change time equal to millis. Okay. Now let's see how this program compiles. I think this is compiling for both the boards now. For now, we only have this Arduino, this one, right? So I think we'll set uh, run. So n. So this n is this environment, which is that I know. So I can just build for that environment. And just key So that will only build for our board. So now you see that I think it's built it, right? Yeah, it's built. So it's set in input pull-up mode. That's why you can see. Okay, that's why we didn't do anything about this, right? Okay, maybe it's. Oh, that's the thing. We haven't said anything about. Oh, we shouldn't do this. Okay, okay. This is one fine mistake that we have here, because LED is not the input thing, right? So that is one thing. Okay. Fine. Push button should be the input pull-up thing. So that is for the second task. So we don't worry about this. Now compile again. Now it should compile fine. And now our this thing will do that, but without any delay. This will do continuously, right? So we don't have any delay with us. Okay. And now we'll go for the task 2, where we do this. And we do this every time, right? We don't have to wait for this. We don't have any delay to use this. So we can just turn that on. Now this won't work, this push button, but now we are enabling it. And then this, now the push button should work. Yeah, you can see when I'm holding it, turns on and it turns on. So now you see the advantage of setting up the local project like this. You can see what is happening internally and how things are going, and also the compilation speed is less than 1 second for me, but it is, takes like 30 seconds in online working thing, right? So it's easier for us to level up and debug. So that's the idea for setting up this. Okay. Now, and we have more flexibility on choosing what actually we need, right? So it will be complex. You need to learn things. I suggest you do some projects in the Arduino IDE or this thing, and then try to come back here. So remember that these things exist. When you want to build a bigger project, you actually will need these things. Okay. Now we have the two functions completed. And what's our task 3? Our task 3 is to,
Using the
yeah,
potentiometer to set up
potentiometer. We have to uh,
blue blue
get the
LED.
blue LED. Okay. So potentiometer to change the value of blue LED. It's LED 3. And we'll define the potentiometer. I'll just check wattmeter, which is connected to A0, right?
Easy, yeah.
And we'll set that input, just input because it's a active input. And for the PWM thing, which is pin 9, right? It's 10, pin 10. The LED P is 10. So task 3. So what is the task? So you need to know this thing. Then uh, okay, yeah, we just do this digital. Instead of digital, we have analog read and write, right? Analog. Also, I think these are others. The LED 3 output. In here, LED 3 output that we need to have. Then we can go with analog read LED 1, LED 3. Just read. But we saw that ranges differ there, right? So we used map function to map the value from the this one analog read from the not LED port meter and map this to. So this value ranges from 0 to 1023, and we should map that to 0 to 255, and then we'll put digital write to oops, yeah, uh, two brackets. What's missing? Missing. Okay. Yeah, digital write. So sometimes writing everything in a single line maybe uh, not look good, and it's not a good idea to do that. So you can uh, have the brightness or just call brightness. So this is our brightness, right? So we'll put that over there. Potentiometer, map the value, and in digital right, we'll use it's not digital right, analog right again, right? Uh, LED 3 brightness. So naming intermediate values also helps us understand the code later. If you forget what you're trying to do, having only digital writes and read won't be better thing to do. So if you map this value, you can know, yeah, we are changing the brightness of the LED using this. So having a meaningful code actually tells something more about meaningful variable names, and this thing actually tells more about the code. Sometimes it is not. We shouldn't be doing this because it takes additional space while you're considering hardware things. This thing takes space, right? And also you can use if you don't want to have this brightness lying around over there, you can always use scopes in C, so that this brightness integer is only present during this computation. So after that, it would go out of the memory. So those things happen. So now let's see the task 3 and see how task 3 works. You compile it again and let's see the brightness. Yeah, brightness. It's going well, right? Okay. Uh, this is great, right?
So the brightness, the thing which you did in the last, the brightness is a variable in which you put the whole code for
Yeah,
only this task.
yeah.
Okay.
Sorry.
Yes,
Uh,
so that's what I'm asking. Yeah.
oh, so now it is.
Brightness is a variable, right?
Yeah, yeah. It's a variable.
Okay.
Okay. Now we have the three tasks done, and this code now does this and also this, changing the brightness. I think the variation of the brightness is not uh, clearly visible. Like,
No,
uh,
so it's visible.
okay, yes. And now let's see the sensor thing. Now we have to do that. So this is how you usually do things one by one. One more thing you need to realize is that all the computations that we are doing are actually how like taking very small time, right? This is actually this seems to work like parallelly because these computations are very small, and that's why we get to see the whole thing behaving in a good way. Correct?
Yes, sir.
What if this takes so this there is a process running around here which will take more computations to do, then these tasks will be not working well, right, together.
Yeah, it will work like an interpreter. First, it will,
Yeah. So
right?
yeah, so then their blocking will happen. So we cannot actually parallelly run the task side by side. So that's one thing we have. Like then there comes a problem of process allocation. I think you have studied this in operating systems kind of course. How our operating system runs everything seemingly parallel by allocating different units of time. So that's where the RTOS comes. So that we'll go later. So RTOS helps us to create multiple tasks and run that parallelly. This is a kind of first attempt towards doing multiple things, right? A simple attempt towards doing that. And task 3, so sorry, task 4. So having this is a good thing because you can also have another LED changing at different interval. That's one thing that let's have the task 4. So for task 4 we need what we're going to do is turn on LED 4 with motion detection. So we'll have to set this thing motion sensor is in pin 7 and sensor digital. We are going to read the motion sensor's output and map it to uh, it is actually similar to something like this. We are going to actually map the value. So this will be there. So now let's compare it again. And now let's simulate motion. I think it's hiding the LED. So we'll keep it here. And you can see the yellow LED is now blinking by detecting the motion. Since all these things are pretty straightforward things and takes less amount of time to do each individual thing, now everything looks like everything is going like that. So this is one pattern that you used to follow when you are doing things like that. Multiple tasks using millis for controlling things that need to be done at different intervals. Okay. So assume you want to let's add one more component to here. We shall add anything else. So, so there is this LED bar graph. This is one thing. Connecting this. There are 10 LEDs around here. Okay, let's not do this now. That would be also good. Let's do one thing. I'll just so how we can organize our code. So do same thing for different LEDs. How we can create a library kind of thing. So now let's keep this diagram. So for this project, I think we try not to mangle with anything. So what I'll do, I'll change this to diagram multi-task session and create. So what I'm going to do is I'm going to remove all these things. So it has 10 pins, 10 digital pins. Okay. So let's connect everything to ground. This is the boring part actually. Put it. We'll start from zero. So it is not a good idea to actually rename files like this. If you want to try a different project, actually create a different project with platform I work like. Now, since we are running out of time, I am doing it in the same thing. So, let's connect the story. So 0 to 9. Okay. Outlets. Okay. So now we'll copy this diagram.json. This with the reader. Actually, we have the diagram.json. We'll close this and start that again. Now we can see. But our code is still the same code that we had. So we have to write our new code. What I'm going to do is I'm going to. mm, this is also not a good idea to do this. Okay. Now this is not my file. Maybe a dot there. So, oh, or else I'll just okay. This is fine. Yeah. Fine. Okay. Now let's we have main.cpp. Okay. This is the input.no setup and loop. Okay. So now we actually want to light up this different LEDs. So basically, these are like 10 LEDs stacked together. Okay. We want to light up different LEDs at different relays. We want to be able to program that easily. How do you do? We saw how Nilis works, right? So how do we do that for 10 LEDs? Do we copy paste things again? Or we build something like represent something? And you also saw for using the list, we need a last change time, correct?
Yes, sir.
And for different delays, if you want to store the delays, you want to also store different delays for different delays. So how do you conceptually bring that together using structs? Now we have an idea. So our idea is concept is a blinking LED is our item peripheral. You can call it like that. And our blinking LED needs a pin, correct? And a delay and last changed. We need these three things for a blinking LED. Is it correct? And now,
So what is the last change time for?
in the last code, if you see, we have used the last change time, last LED change time to update the state, right?
Yeah, yeah, yeah. Still.
Yes, we need that for different. If we are using different delays for different LEDs, we need each last change time for that, right? For
Mhm.
a particular LED.
So the other LED code don't block the code of the next one, right?
Yeah, yeah. That's the idea. Okay, so we need these things, and now we are going to uh, blink the LEDs actually. Blink. We'll take in anything is saying some support expected at semicolon. Things a semicolon anywhere. Construct anything here. Is there. Now it's clear. Yeah. So in the blink function, you'll actually take in an LED, not a full LED. You can just take the LED reference to that LED, which is a struct uh, blinking LED pointer, the pointer to a blinking LED. And now we'll just take the code from there. This is how we change the thing there. Right? Now we have LED last change time and LED delay. Millis is the same thing, and here it is LED dot pin. This is LED dot pin. So now we have adjust our blinking delayed blinking code like this, just like that, as a function that accepts a blinking LED structure. So now what are our pins? 0 to 10, right? 0 to 9. So we have to store all these things, right? The blinking LEDs. How do we store all these things? We need 10 LEDs. Use that. What do we use? We need to store 10 blinking LEDs, right? How do we store them? Any idea?
Sir, what?
So we need 10 blinking LEDs. So we have a structure for one blinking LED and we need 10 of them. How do we create? Like how do we create and how do we store them?
We can make a like what we did the last time, the brightness type of kind of, we can make another variable and then copy paste it 10 times.
Oh,
That
we
would
create
create
a array.
mess. Yeah.
We create an array. Struct blinking LED array with 10 blinking LEDs. We just initialize that way, don't worry about the settings. Uh, we missed something. What is that? Structure, bounding, declaration. It's the same. Oops. Yeah. It's initialization. Okay, we have to initialize this. Wait. File. Oh, okay. We use square brackets. Okay. Oh, sorry. The thing was, we didn't declare the variable name. That was the thing. Oh, I think we don't need to initialize it now. We'll initialize because we know what are the numbers. We can actually initialize them using a for loop. So I don't have to initialize them. So we need a whole bunch of setting pin modes and things, right? We use for loop for that. Equal to 0 to 10 plus plus. We're going to do pin LED uh, node I, which is the current LED, to output. Also, all the LEDs will be set output. And also, we are going to change these things. LEDs of I dot pin will be I, that we know. And I'm going to set the delays as, so each LED will have a 100 ms delay in their blinking frequency. So starts from 100 into I plus 1. Since I is starting from 0, we need blinking from, I think 100 would be too low, that we may maybe not notice. I'll start with 300 ms. So what this says, the ith pin will, so the 0th pin will blink at 300 ms. The first pin will blink at 400 ms. Second pin 500 ms. Third pin 600 ms, and it goes on like that. We are setting the delay like this. And LED of I dot last change time, uh, we'll set it to 0 because we assume everything is last changed during the startup. So this is the first loop that we are going to set. And how do we do this in the loop? Write a loop inside a loop. Same thing. We are going to call LED blink, our blink function, with LEDs of I. So LEDs of I is a actual LED, and we are going to actually pass that address to the LED, right? One way to do this, you use address of operator and do this. So it passes the address of the ith LED for us to the blink function. Okay. Now the blink function will take care of the delays of each LED and delays of. Now see, by structuring our code in certain way, by doing the repetitive things, we can have a very cleaner code that will do the job for us. And now we are going to check if it works well. I think no output. Okay. No. Let's see. Something. Are we missing something? Write to output. Maybe spin to I. Everything is connected to the line. And this is also funny. Something missing. The blinking function. Are we missing something here? Let's change time greater than that. Everything looks fine, right? Maybe I'll just open this file, just make it paste. So that this is connected to ground. So connected to ground. Ground. Should be working. Maybe the pin set is it. Let me check reset the code once. Start from, let's check with pin 5 to 10. This, okay. Still LED pin, right LED pin. Yes. Let's restart this one. Okay. Oops. We have connected the wrong side. Anode should be connected to the positive pins and cathode should be connected to the negative pins. Okay, so what do we do? Connected. I'm going to change these things using a bit flag, but I'm not sure how it will affect the diagram. Change this to 2K. This to okay. Let's see how it looks like in diagram.json. Good. Okay. Now it is not looking good. It is overlapping kind of things. But for now, bear with it. I think it's not doing things properly. One thing we can do is one quick thing we once LED check this one. We update it. Have LED with rotation. I'm going to. I think we can flip this thing, right? Let's check flipping this. That will help us here. Color Let put this second. Wait, let 280 degree. This is better, better than that, right? Yeah. So now we'll go from here is our code that blinks all the LEDs at different intervals. So it just looks like a random thing, right? But it's actually, if you just focus on one LED, it is blinking at a particular relay. Is that clear? Any doubts still now? So how many of you have explored what are the different components that are available in Workday? Have you checked that? How many of you checked the projects in Workday? Or how many of you checked anything about what we saw yesterday? I just came back.
Yes, sir. First of all, checked the piano. There was a project called piano. I tried to make it, and but the I can't understand the code part that much well.
The piano with the
Yeah,
push buttons.
yeah, yes, sir. And also the joke machine. I found it interesting. But the thing is, the connectivity part of the thing. Like, I guess I can make the code, but how do we make a connection with the internet through the coding part?
Connectivity to the internet.
Yes, sir.
So that is a project with the ESP thing. Uh,
So,
which project is that?
joke machine kind of.
Okay, I'm sure, but I'm just no, some future projects. You saw this one, right? This mini piano.
No, sir. It
This
was in the home page.
the homepage. So the mini piano is what? This one, right? This one.
Yes, sir. Yeah.
Yeah. So these are like kind of advanced looking projects. You might not start with this, but I think piano is kind of fun. It is
No, I only made only used only one button and the speaker. I
okay.
didn't use these. I only used one button only.
Okay, they are using pictures.h to actually store the different nodes values at constants, and they are taking it here, basically having an array, just like how we did stored each. We we provided a structure for our LEDs, but
Yeah.
buttons just need
Yes, sir.
pins. So they are using an
Yeah.
array
Are you? Yes, sir.
and an array for nodes, and they are calculating the number of nodes by this, like how many elements here are there, and just like our code now just did a for loop, they are setting a pin node. And for speaker, there is only one. They are doing this. So if you see the comparison between our code and that code, it has more similarities because it has common elements,
Yes,
same
sir.
elements, right? Similar elements which have the same functionality, which can be automated using a for loop.
Hmm.
So that's why they are also using that and reading the buttons. If it is low, this is basically just setting the pitch. They are reading a button, then setting a pitch according to this one. They have the notes there, right? If button is that, play that note. That's what they're doing. So this tone function here will actually generate a particular frequency, a tone of that frequency with it. So I hope this will be uh, connected here. So it will actually turn on and off the GPIO pin in that particular frequency. That's why you will hear that sound in
Yes,
the
sir.
whistle. I hope when you play this, you can actually see it working. Hope you can hear the audio also. You can change the notes to a higher level. So if you change this force to 5, it oops, uh, a higher no. You see, if I try to compile it over here, sometimes it compiles, sometimes it takes more time based on the server availability. But for our thing, in the local machine, it will take lesser time. Now it's in a higher pitch. So one more thing about this project is actually in what we can assign uh, keyboard values to each push buttons. So they have actually assigned number 1 to 8 for this thing. So I can actually play this piano with the keyboard. Because I'm not a good piano player. It is up there. Okay. So so I think now I should leave this session open for you to tell your thoughts or your project ideas, something like that. It might be good to hear from you. Like, is this doable? Questions like, is this doable? Can we do something like this? Or if you want me to demonstrate something tomorrow, you can ask now. Like anything, anything. You can tell about anything that you want to know or ask me. Yeah.
So can you please tell us about how the different kind of functions, like in the Arduino IDE, there are many different kinds of functions, but I can't understand how they work
Okay.
different with different settings.
So you understand the concept of GPIO, right? How
Yes,
we
sir.
manage
Yeah,
input and output.
yeah, yeah.
So those related functions are there. So let's go to the Arduino reference.
Like the analog and the digital write and digital read, I understood those kinds of codes, but there are also, yeah.
Okay. So we have studied analog IO, digital IO, and there are this advanced IO things. Basically,
Yes, sir.
this no
Please.
tone and tone are used to generate pulses by turning on and off the GPIO pin. Actually, right? So it will actually interference with like interfere with the outputs of pin other than mega. Like it gives some actual functional things about that pin. But the idea is to have a pin frequency and duration. How much time and how much frequency your pin is. Okay. And no tone will turn off the tone. It says that just to zero. If you want to play different pitches in multiple pins, you need to call no tone before calling the other tone. Like that's why the no tone is there after interlude. So you have some examples over here. So each thing we actually learn by seeing the examples. What I suggest is if you want to learn different functions that are there in the Arduino reference, go to a function. Just read through how what does that function does, right?
Yes, sir.
Generate square waves using that, right? And also there are some samples. In the Arduino has like very well documented things if you want to start learning. You have a tone keyboard, right? So this is basically what we saw there. Three buttons and a speaker. So they have used the 10 button thing. There this project is for 3 button. I hope this is actually the pictures that is taken from this one. You can take this from here, right? Playing a melody with the tone. So how do you play a melody? Just take the notes for maybe a little lamp and put it there, and it will use a for loop to just change the frequencies and stuff, like an array and the note durations. What note to play, the note is to play. And this one you can just play with a for loop, right?
Yeah, this node function we also use in the piano.
Yeah,
Is it?
because it is also we are generating sound, right? So piano is from input to sound. Here we are playing a pre-recorded melody,
Yeah, yeah.
sequence of notes with sequence of durations, right?
So it is not only one function. There are different modules doing different tasks regarding that one
Yeah.
function.
This is not like it is a recorded. So basically, this is a recorded melody, and we are going to play this in a loop forever.
Okay.
That's what this is about. So you will get this different examples from here. For each thing, we'll get to know how you can uh, do things like, for example, yeah, learn with projects. That's the best way to learn things. If you want to learn about a function, search the function, go to examples, see how that function is used. You need to spend time on how each function work, right? Then you
Okay,
try
sir.
out for yourself, then try to modify that with a simple thing like this is doing that. What about if I want to do this with this?
Yes, sir. Trying different things with the same function. Okay.
Yeah. So now here we have created this blinking LED, right?
Yes,
Our
sir.
blinking LED is doing different delays. What if I want to uh, generate like I given a number 10 bit number like an integer number. I want to represent the uh, binary value of that here. You can write a code for that, right? With the same diagram. How do you do that? So creating problem statements by looking into it yourself, that would be a good place to start. Exploration. And when you got stuck, how do I do this with that? Then you go here and see that. Okay? And trying out different components, different sensors. So most of the components will require a library that you need to use. Uh, I think maybe we'll look at something that we use a library like the communication protocol. And one more thing, I think we have time. We have this time, right? So tomorrow, what I'll do, I'll talk about the interrupts and the timers. And what I would suggest is, uh, at least some of you try out something, and if you could show what you did with what and what you tried, like a 5 minute talk about what you did tomorrow, it would be good. So, of what you have learned today, like it could be just I tried out platform. I was setting up things with that. I tried out some this simple project with that. That would be great to know, right? Yeah, that's good. Okay.
Hello, sir.
Yeah, yeah. Cliff.
Actually, I don't. I just want to know about what is actuators and all, like
Ah,
how manage that things and all.
okay. So actuators are the moving parts in a robot, right? You have the servo, stepper motors, actual motors,
Okay.
which controls physical motion. Those are that devices. So
Oh,
actuators are those devices which controls the physical motions or movement. Those things. Sensors are which produce. So if you see about sensors and actuators, sensors convert a physical value, physical quantity to bits, a readable value.
okay,
Actuators convert a sequence of bits to a physical quantity like moving or something like that.
okay.
So that's the difference. So if you see in Walkme, you have set of actuators and things there in the components. See this.
Yeah, I have seen some servo and
Yeah,
yeah.
these are the actuators actually. This convert bits to a physical quantity, right?
So
That's
buzzer is also a type of servo, is it?
sorry,
Buzzer is also a type of servo. Sorry, this actuator.
actuator. Yeah, you can call it actuator.
Okay. So anything that is converted into physical form is an actuator, right?
Yeah,
Okay.
like some physical quantities. It can be sound. So actually, how sound is produced by moving?
Yeah, by physical movements.
Yeah, right.
Right.
Uh,
Okay.
Sensors actually convert this. So there is different type of sensors. From these sensors, some of the sensor actually work with GPIO, but other sensor, for example, this MPU. If you see this, this has multiple pins, and if you see closely, it has this SDA and SCL, which are the pins used for I2C communication.
Right.
So we'll see this tomorrow about these different communication protocols. How
Okay.
that actually what's happening is along with the sensor module, it has a processor like some small IC or something like that that actually converts the GPIO value, the input values that it receives, since it has internally multiple sensors. So this MPU actually can have produce 7 values. So how do you send these 7 values with a single pin, just like our PIR sensor just had one pin for our data, right?
Right.
But this module actually provides us 7 values: temperature and motion in like acceleration in 3 axes and rotation in 3 axes. Totally 7 values this module provides. So we need a data transfer protocol to communicate, send those values in a proper manner. Correct. So this sensor, so this is actually this whole module, but we call it a sensor, but this has all different sensors combined into a module, and the data is transferred over is a particular communication protocol.
Okay.
So some sensors will use serial protocol, some sensors will use SPI protocol, those things, and you can communicate using serial between different devices. Those things can happen. So we'll see how we can do that. I'll demonstrate how we can use this. So if you see here in tomorrow's session, so you get the idea about how we set up the project and how we get to code. And after that, I'll so here in this language reference, we'll discuss about interrupts. This part, interrupts, how interrupts we can use interrupts, and how we can use these libraries. I hope serial library it is easier one to discuss because Arduino had a very good API for doing this. I2C is a address based communication that we use using the wire.h, this wire library for I2C communication, right? So there would be this I2C pins and how we send and receive data with this. Yes, someone having this. Yeah, Arunya.
Sir, I wanna ask like I2C and serial both use like one-way communication, right?
Uh, I2C is serial is one way communication. No, no, right? It is two-way communication. It can transmit and receive.
Sorry, wrong. Sir. I mean to say basically one signal at a time. Basically, yeah, it can do two-way communication, but basically they can only talk to one device at a time, now.
I2C is an address-based communication. So multiple devices can be connected to a same I2C line. So you have multiple peripherals connected to same I2C lines. So you can just pick an address to communicate with that particular peripheral that is connected. So you can actually connect multiple peripherals to a single I2C line. We'll show that. We'll see how we can do that. Okay.
Okay,
Tomorrow we'll discuss these things.
okay.
Uh, I hope I'll try to cover many things, but we haven't gone through it. Maybe we'll have also after this session goes. Maybe later we'll have another after some days. Maybe we'll have another set of thing that would be also good.
Yes, sir. Sure, sir. We will love to have sessions.
Yeah. So for now, I think today this is fine. Anything else you want to ask? Okay, good. I think
I
Akhilesh
don't
you
think
can
so.
close it.
We can wrap up now.
Yeah.
So thank you everyone for your time. Thank you, sir, for coming. Good night, everyone. Good night, sir.
Yeah.